Hi, welcome back, Hononegah. Honors, Algebra 2, Section 5.5, Performing Function Operations. Basically, what we're going to do is add, subtract, multiply, and divide with polynomial expressions. And these are not necessarily simple polynomial expressions. A lot of times they'll have radicals and things like that. So here we go. Adding, you're just going to add like terms. Subtracting, you would subtract like terms again. Multiplying, going to multiply the two together, and dividing. Now, the one thing I will say is about the domain. Anytime you have a radical, an even radical, I should say, or anytime you have a fraction with a variable on the denominator, you always have to worry about the domain, like a value of x that you're not allowed to have. For example, this particular fraction right here, x actually cannot equal -2. Because if you had -2 for x, it would cause the denominator to be 0, and you cannot divide by 0. So again, anytime you have a fraction with a denominator with a variable, or you have a radical, an even radical, then the domain does come into play. So here we go. Let f of x equal 5 square roots of x and g of x equal -8 square roots of x. Find f plus g. So they want me to take the f function plus the g. So here's the f function plus the g function. So 5 square roots of x plus -8 square roots of x would be -3 square roots of x. So this is what f plus g of x would equal. Now, what about the domain? Well, domain would be x just basically can't be less than or equal to 0. So as long as you don't have any negative numbers, this is okay. And then it wants me to evaluate, so that's one answer. The domain is the other answer. And then they want me to actually plug 16 in for the function. So -3 times 4, and evaluate, you get -12. So there's three answers here. Finding the addition of f plus g, finding the domain, so the domain values you're allowed to use in the question, and then evaluate when it's at 16. Next, f minus g, and this one's a little bit longer. 2x cubed plus 4x squared minus 8x plus 4, there's f, minus g. Now, this goes back to basically chapter when we're adding and subtracting like terms. And so I got to make sure I subtract all of those, and that is the common mistake. So 2x cubed minus 3x cubed would be -1x cubed. 4x squared minus -5. So now we're talking about a plus 5, so 9x squared. -8x minus 6x would be -14x. And 4 minus a negative, so that's like adding, be 13. Some of you who struggle on this may want to consider rewriting the question and changing all the signs. Oops, that moved down on me, so hold on one second. Changing all the signs. So this would be in -6x plus 9, and then add like terms. So again, that's another way of doing it. Domain, because there's no radicals and because there's no fractions, the domain is all real numbers. And then evaluate at -1. So now they want me to put -1 in for all the x's. So if I put -1 in for all the x's, I end up getting 1 plus 9 plus 14 plus 13. So -1 cubed is -1, and there's a negative already on the outside. So 20 would be 37 would be evaluated. F times g. Now this gets a little more challenging. F of x times g of x. Now I'm going to go ahead and change this into x to the 1/2 power, because that allows me to do a little bit more. X cubed times x to the half would be, you can add exponents, would be 3/2 or x to the 7/2. I wouldn't count it wrong if you had x cubed square root of x, because ultimately that's just leaving it as a radical. So that's the f of x times g of x. And now, domain. Remember, you had a radical in there, and it's an even radical. So the domain must be x is less than, or x cannot be less than or equal to 0. And I should have changed that earlier. I'm going to go back to the previous slide here. Some of you may not like that, but the domain is actually x is greater than or equal to 0. So again, going back a couple slides here, it's not the domain is x is less than or equal to 0. That's what you can't have. So I apologize. It's actually x is greater than or equal to 0 is the actual domain. Now they want me to evaluate. They want to evaluate when x is 4. So I want 4 cubed times the square root of 4. So 64 times 2, which is 128. It would be the same as if you did 64 raised to the 7 halves power. It would be the same as raising 4 to the 7 halves power. So that would also be 128. F divided by g. So I want to take 4 of x, or 4x, and divide that by x to the 2/3. Now, F divided by g. You're not allowed to have a fraction exponent in the denominator. So I'm going to multiply by x to the 1/3. So that makes x in the denominator. Now I'm going to go back here and start over. 4x over x to the 2/3. Because the top is larger than the bottom, I didn't have to do that, so I apologize. X to the first, and so when I subtract the exponent, x to the 3/3 over x to the 2/3 makes x to the 1/3. So I apologize for that. I was going to do something, and then I was going to end up having to reduce it in the end anyway. Domain, because your radical is a cube root, the domain would be all real numbers. And then now you want me to put 27 in. So 4 times 27 to the 1/3 power. 27 to the 1/3 power is 3. And so 4 times 3 is 12. So there's 3 answers here. Now they want me to use a graphing calculator to evaluate. So I'm going to have to pull out a graphing calculator here. F plus g, F minus g, F times g when x is 3, and round your answer to 2 decimal places. So they want to know what square root of x plus 20 minus x squared is. They want to know what the square root of x minus square root of 20 minus x squared. They want to know what the square root of x times 20 minus x squared, and then the square root of x divided by 20 minus x squared. So now they want me to put 3 in for each of the x's, and again, this will end up being a decimal answer. So let's pull out our let's hit pause. Go ahead and type each one of those in, and then I am going to just write the answers down. So again, put 3 in place of the x's, and type this into your graphing calculator. All right, welcome back, and let's write all these answers out. So basically, you're putting 3 in. So you got the square root of 3 plus the square root, and I went ahead and put the 3 in. So 3 squared, 20 minus would be 11. So the square root of 3 plus the square root of 11 would be 5.05, rounding to 2 decimal places. The next would be the square root of 3 minus the square root of 11, which would get you negative 1.58. Square root of 3 times the square root of 11. You get 5.74, and then the square root of 3 being divided by the square root of 11, you end up getting 0.52. In 2010, the population of cities M and N can be modeled, where T, and so M of T and N of T, where T is the number of years since 2000. Find M minus N. So this is going to be a little bit longer, but 3.3 T cubed, 12.1 T squared, 0.65 T, and 15.8 minus 2.5 T cubed. And remember, you're subtracting this whole thing, plus 7.8 T squared, plus 0.41 T, plus 11.9. Remember, you're subtracting all of those as you go through this. So 3.3 minus 2.5 is 0.8 T cubed. 12.1 minus 7.8 would be 4.3 T squared. So I got those are gone. This one is gone. Negative 0.65 minus 0.41 would be negative 1.06 T. And then 15.8 minus that one. 15.8 minus 11.9 would be 3.9. Explain what the function m of t represents. They took the population of m minus the population of n, so it'd be the difference between the two cities' populations. So it's the difference between the two cities, or how much bigger city M is compared to city N. Your homework assignment is out of the book. If you have any questions, please make sure you talk to your teacher, and good luck.